Here are some examples of problems about properties of real numbers. Problem 1. What sets does 17 belong to? The sets being considered here are the reals, rationals, irrationals, integers, whole numbers, and natural numbers. So let's check each one of those individually. Is 17 a real number? Yes, it is. Now, is 17 a rational number? Since 17 is actually an integer, we can write it as 17 over 1, which is a fraction of integers, therefore it is rational. Next, the irrationals. Since 17 is rational, it can't also be irrational. Now it's clear that 17 is an integer, so it's in Z. And it's also true that 17 is positive, so that means it's a whole number, and it also means it's a natural number since 17 is not equal to 0. So these are the sets that 17 belongs to. Problem 2. What sets does minus square root of 7 belong to? Again, the sets we're considering are the reals, rationals, irrationals, integers, whole numbers, and natural numbers. Starting with the reals, it's pretty clear that minus square root of 7 is a real number. Now let's see if it's rational. We know that the square root of a number can only be rational if it's actually an integer. But there's no number whose square is 7. That's also an integer. 2 squared is 4, which is too small, and 3 squared is 9, which is too large. So square root of 7 must be irrational, which means that minus square root of 7 is also irrational. This means that minus square root of 7 can't be a rational number. In particular, we know that all integers, whole numbers, and natural numbers are also rational numbers. This means that minus square root of 7 cannot be an integer, a whole number, or a natural number, since it's not even rational to begin with. So it's only a real number and an irrational number. Problem 3. Simplify the expression 3x plus 4y minus 6x. First, we write this out. 3x plus 4y minus 6x. Now notice how there's two terms that have x in it. If we put these next to each other, we have 3x minus 6x plus 4y. Now we can use the distributive property to combine them. This is equal to 3 minus 6 times x plus 4y. 3 minus 6 is minus 3, so we're left with minus 3x plus 4y. Problem 4. Simplify 1/2 times 16 minus 4a minus 1/4 times 12 plus 20a. First, let's write this out. 1/2 times 16 minus 4a minus 1/4 times 12 plus 20a. Now for each half of this expression, we can use the distributive property. 1/2 times 16 minus 4a is going to be 1/2 times 16, which is 8, minus 1/2 times 4a, which equals 2a. And for the other half, we get minus 1/4 times 12, which is 3, minus 1/4 times 20a, which is equal to 5a. Using commutativity, we can switch these terms around and write this as 8 minus 3 minus 2a minus 5a. Now this is equal to 5 plus minus 2 minus 5 times a. We can combine the a terms using the distributive property again. And finally, we get 5 minus 7a.